One thing I want to be clear about is, what does it mean to have a solution to an equation? So when we're talking about the solutions for an equation, the answer is that the solution is the value for the variable. So we're finding a value for the variable, but the specific value for the variable is the one that makes an equation a true statement. So that may seem a little bit confusing, but for example, if I look at this x plus 3, if I was to look at this equation right here, right? If I was to say, oh, well, because I know that x is a variable, and we often say that variables can be any number. What if I said that x was equal to 1? So if I said x was equal to 1, is that a true statement? Does 1 plus 3 equal 16? The answer is no. This is a false statement. 1 plus 3 does not equal 16. This is false. And therefore, x is not equal to 1. Okay? So what number do we need to add to 3 to get 16? Well, if you do a little thinking about it, you'll come up pretty quickly with x equals 13. Right? And then we check that. 13 plus 3, does that actually equal 16? This is true. So yes, x does equal 13. Now, are there any other numbers that we could add to that we could add 3 to get 16? No, there are no other correct answers. So if I was to do, if I try any other numbers, even numbers that are really, really close, even like 13.1, like what if x was like 13.1 or 13.01? 13.01 plus 3, does that equal 16? Let me write that better. Plus 3 equals 16. This is false. It actually equals 16.01, which is not 16. So x cannot equal 13.01. It has to be exactly 13. That's the only thing it could be. It can't be anything else. So this is our solution. So we know, check. We're going to put a check right there. X equals 13. That is the correct answer for this one. Another example over here, 4 times a number equals 20. So if we do that math, if we were to say same thing, like what number do we multiply times 4 to get 20? Now, if you think about that for a minute, you'll come up with x, if x equals 5. If x equals 5, then 4 times 5, does that equal 20? Is that a true statement? And the answer is yes, this is true, because this is true. This is true. Therefore, x, therefore is these 3 little dots right here. Therefore, x equals 5. So I know this is correct. And if I was to try other numbers, like if, let's go back to some of our false colors here, like pink. If x was equal to 3, then does 4 times 3 equal 20? This is false. 4 times 3 equals 12. It does not equal 20. So therefore, x cannot equal. The little slash through means it's not equal to 3. There's no way. So when I'm circling my answer, right, that's my correct answer. Okay, so now we're going to use that for the same, like that same thing applies to bigger expressions. So there are different types of solutions, and we're going to see what they look like. But the question is, does my answer make the equation true or not? Is really what we're asking. So I'm going to zoom in on this one first. You guys should already know the simplifying steps, so I'm going to walk through those pretty quick. When I'm solving this one, my first simplifying step, I always recommend you guys do keep, change, change, which means change all of the subtraction to adding negatives. And then the next thing I do is I try to combine like terms. So I see like terms here to combine. So 2x plus 3x, that is going to make 5x. And then everything else is the same. So 5x plus 7. And then over here I have 6x plus negative 3. All right, and then there's no zero pairs here, so the next thing that I need to do is I need to remove balance sets. So I'm going to take like something away from both sides using inverse operations. It doesn't really matter what I take away. I'm going to start with the x's, so minus 5x on this side and then 5x on this side. So if I take those away, then my simplified equation will say that 7 is equal to, instead of 5x, it is going to turn into, or instead of 6x minus 5x is 1x. And this over here, this is of course 0x. And then plus negative 3. And then let's see, because I know when I'm solving that I want to get all of the x's on one side and all the numbers on the other, I have to get rid of this negative 3. So I'm going to try to do that next. So I'm going to subtract negative 3 and then subtract negative 3. Some students get confused by this. Some students think that this is like adding or subtracting positive 3, and they say it's the same thing. So just to help me clarify, I'm going to do keep, change, change again, where I keep negative 3, so I'm going to do negative 3 plus positive negative 3 instead, and 7 plus 3 instead. And that is going to turn into 7 plus 3 is 10 over here. And on the other side of my equation, 1x minus plus negative 3 and then plus positive 3, that is going to equal, just 1x. So now I have 1x is the same as x. So I have all of my numbers on one side and all of my x's on the other. I've simplified this equation, and here I see that my answer is, so I have x all by itself. So, so I'm saying that x is equal to 10, and I'm saying that this is the solution to this problem. So then just to make sure, like to prove it, just to make sure and prove it to myself that this solution does answer, I'm actually going to do what's called the answer check. So the question that we're asking when we start this problem is, what number times 2 plus the same number times 3 plus 7 is equal to 6 times the number plus negative 3? Or another way we could say it is, what number does x have to be for 2x plus 3x plus 7 to equal 6x plus negative 3? And so in solving all of this, my math has determined that 10 is the number that x has to be for those to be equal. But you know what? It's kind of hard to do in your head sometimes, so I'm actually gonna go figure that out. So 2 times I'm gonna do 2 times 10. If x is 10, these should be equal, and then I'm going to just find out. And then 3x means 3 times 10, so I'm going to do 3 times 10. And then plus 7. And then 6x means 6 times x, so I'm going to do 6 times 10. And then I'm going to do minus 3. That was the original equation. So now let's figure this out. Let's simplify this. What is 2 times 10? 2 times 10 is 20. 3 times 10. 3 times 10 is 30. And 6 times 10. 6 times 10 is 60. And then everything else, nothing else is getting multiplied by 10, so I'm just going to write all that in. So now I'm wondering, does 20 plus 30 plus 7 equal 60 minus 3? So I'm going to add some numbers together here. 20 plus 30 plus 7. 20 plus 30 is 50. Plus 7, this is all going to equal 57. And then on the other side, I'm going to do 60 minus 3. What does 60 minus 3 equal? Well, that equals 57 too. And my equal sign goes between them. So this is the question. When x was 10, this side was equal to 57, and this side was equal to 57. So that means, yes, this is true. This is my solution right here. And does it mean that x is 57? No, it does not mean x is 57. It means that when x is 10, sorry, my solution is actually up here. When x is 10, these two things both equal 57. So that's how I know that my answer is correct. The next thing, though, is what happens if you make a mistake? Like, is this always going to work? So I'm actually going to zoom in and show a mistake. I have a very common mistake that students make, and I actually mentioned it earlier. If a student does 7 minus -3, oftentimes I will have a student that will do 7 minus -3, and they will say that that is equal to 4. And they will do the other side. They will go, oh, well, I knew that I was getting rid of this -3, so that's 1x, but then this side is 4. And so they'll come up with an answer of x equals 4. Now, this is a mistake answer. This answer is incorrect. This is a mistake answer. But that's all right. We're going to use it, and we're just going to learn. We're going to learn from our mistakes, which is like the best thing that mathematicians do. So if somebody did come up with x equals 4, then they would need to prove it. They would say, okay, well, what's going on? 2 times x is the same as 2 times 4, and then plus 3 times x is the same as 3 times 4, and then plus 7 is just plus 7, and then 6 times x is the same as 6 times 4, and then minus 3. So let's do all of this math together. So when I do this math, 2 times 4 does not equal 20 like it did above. It equals 8. 3 times 4 does not equal 30 like it did above. It equals 12. 7 still equals 7. So that will become 7 still. And then we have 6 times 4. And 6 times 4 is equal to 24. So I'm going to rewrite all this stuff in, all the other things that weren't math that I just did there. So 8 times 8 times 12, or sorry, 8 plus 12 is, let's do this math. 8 plus 12 is 20, plus 7 is 27. And then on the other side, I have 24 minus 3. Does 24 minus 3 equal 27? No, it actually equals 21. And so in this case, is this a true statement? Is 27 equal to 21? No, it's not. So I can tell by looking at this that when x equals 4, these expressions are not equal.